What if the key to solving some of Earth's biggest challenges lies not on our planet, but on the moon? Right now, a groundbreaking transformation is taking place hundreds of thousands of miles away, where artificial intelligence and robotics are converging to unlock the moon's hidden riches. This isn't just about mining rocks or dust, it's about accessing rare resources that could redefine how we live, work, and explore the cosmos. From fueling next-generation technologies to enabling humanity's expansion into space, the moon is becoming the ultimate frontier for innovation. But how do we extract these resources? What role does AI play in this daring endeavor? And what does it mean for the future of life on Earth and beyond? Together, we'll uncover the mysteries of moon mining, explore the cutting-edge robots making it possible, and discover how this lunar treasure hunt could shape the destiny of our species. This is the story of humanity's next giant leap, and it's happening right now. The story of moon mining begins not with shovels and drills, but with imagination. For centuries, the moon has been a source of wonder, inspiring countless stories and dreams. In the early days of science fiction, writers like Jules Verne and H.G. Wells imagined lunar expeditions, planting the seeds of a bold idea. What if we could harness the moon's resources? These tales weren't just entertainment. They were a glimpse into humanity's potential. Fast forward to the 1960s and 70s, when the Apollo missions not only put humans on the moon, but also brought back samples of lunar soil and rocks. Suddenly, the idea of mining the moon wasn't just science fiction, it was science. But turning that idea into reality required more than just ambition. Early attempts to explore lunar resources faced significant hurdles. The technology of the time simply wasn't advanced enough to support the complex operations needed for mining in such a harsh environment. It wasn't until the rise of robotics and artificial intelligence that the dream began to take shape. These technologies allowed us to envision a future where machines, guided by sophisticated algorithms, could navigate the moon's rugged terrain, extract valuable materials, and even process them on site. Today, the vision of moon mining is no longer confined to the pages of books or the ambitions of a few scientists. It's a global effort, with space agencies like NASA and ESA teaming up with private companies to push the boundaries of what's possible. These collaborations are paving the way for a new era of lunar exploration, one where the moon isn't just a symbol of human achievement, but a vital resource hub. From rare earth metals to water ice hidden in shadowed craters, the moon holds the keys to solving some of Earth's most pressing challenges and unlocking humanity's future in space. This journey from dreams to reality is a testament to human ingenuity and perseverance. It's a reminder that the most extraordinary ideas often start as whispers of possibility, waiting for the right moment and the right technology to bring them to life. Now, as we stand on the brink of a new lunar frontier, the question isn't whether we can mine the moon, but how far this endeavor will take us. So, why the moon? What makes this desolate, cratered world so valuable to us here on Earth? The answer lies beneath its surface, where a treasure trove of resources waits to be unlocked. While the moon may appear lifeless and barren, it's anything but. Hidden within its dusty plains and shadowy craters are materials that could revolutionize industries, power clean energy, and even propel humanity deeper into space. Take water ice, for example. Found in permanently shadowed regions near the moon's poles, this frozen resource is more than just a potential source of drinking water for future lunar settlers. It can be split into hydrogen and oxygen, creating rocket fuel that could power missions to Mars and beyond. Imagine a lunar gas station, where spacecraft refuel without the need to carry heavy propellants from Earth. This alone could drastically reduce the cost and complexity of deep space exploration, making the moon a critical stepping stone for humanity's journey to the stars. Then there's helium-3, a rare isotope that's incredibly scarce on Earth but abundant on the moon. Why does this matter? helium-3 is a potential fuel for nuclear fusion, a clean, nearly limitless energy source that could meet Earth's growing energy demands without the harmful byproducts of traditional nuclear reactors. While fusion technology is still in development, the Moon's helium-3 reserves could one day power our cities, industries, and even entire economies, offering a sustainable alternative to fossil fuels. And let's not forget rare earth metals. These elements, essential for everything from smartphones to electric vehicles, are becoming increasingly difficult to mine on Earth due to environmental and geopolitical challenges. The Moon, however, is rich in these materials, offering a new frontier for resource extraction. By tapping into lunar reserves, we could alleviate the strain on Earth's limited supplies, reduce the environmental impact of mining, and ensure a steady flow of materials needed for advanced technologies. But the Moon's value isn't just about what it has, it's about what it represents. As Earth's resources dwindle and our population grows, the Moon offers a chance to rethink how we approach sustainability and resource management. It's a blank slate, a place where we can develop new methods of extraction and processing that are more efficient, less wasteful, and environmentally conscious. By learning to harness lunar resources, we're not just solving problems for today, we're laying the groundwork for a future where humanity thrives both on Earth and in space. The Moon isn't just a rock orbiting our planet, it's a gateway, a place where science, technology, and ambition converge to create opportunities that were once the stuff of dreams. And as we uncover its secrets, we're not just exploring a new world, we're shaping the future of our own. At the heart of this lunar revolution are AI-powered robots, the unsung heroes making moon mining possible. These machines are far more than just advanced tools, they're the brains and brawn of the operation, designed to thrive in one of the most unforgiving environments imaginable. Picture this, a robot no larger than a small car, navigating the Moon's jagged, crater-filled landscape. Its sensors scan the terrain, mapping every rock and shadow, while its AI algorithms process the data in real time, plotting the safest and most efficient path forward. This isn't science fiction, it's the cutting-edge reality of lunar robotics. What makes these robots so remarkable is their ability to think and act autonomously. Unlike traditional machines that require constant human input, these AI-driven systems can make decisions on their own, adapting to unexpected challenges on the fly. For instance, if a robot encounters a boulder blocking its path, it doesn't freeze or wait for instructions from Earth millions of miles away. Instead, it analyzes the obstacle, calculates alternative routes, and adjusts its course, all within seconds. This level of autonomy is crucial for moon mining, where communication delays and the sheer remoteness of the environment demand self-reliant systems. But autonomy is just one piece of the puzzle. These robots are also precision instruments, capable of extracting resources with surgical accuracy. Equipped with specialized drills, scoops, and processing units, they can identify, collect, and even refine materials like water ice or rare metals directly on the lunar surface. Imagine a robot delicately extracting a sample of helium-3 from beneath the Moon's dusty regolith, or carefully melting ice from a shadowed crater to produce water. These tasks require not just mechanical strength, but also a level of finesse that only AI can provide. Of course, designing robots for the Moon isn't without its challenges. The lunar environment is a harsh and unpredictable place, with temperatures swinging from scorching heat to freezing cold, all under the constant threat of micrometeoroid impacts. Add to that the Moon's low gravity, which affects how machines move and operate, and you've got a recipe for engineering headaches. To overcome these obstacles, scientists and engineers have had to rethink everything from materials and power sources to software and hardware. The result, robots built to endure the extremes, powered by solar energy or even small nuclear reactors, and insulated against the Moon's relentless conditions. What's truly exciting, though, is how these robots are paving the way for a new era of space exploration. they're not just mining resources, they're laying the groundwork for future human missions, building infrastructure and testing technologies that could one day support lunar bases or even colonies. Every scoop of soil they collect, every experiment they conduct, brings us closer to a future where the moon is more than just a distant destination. It's a thriving hub of activity and innovation. These AI-powered robots are more than machines, they're pioneers charting a course for humanity's next great adventure. And as they explore, extract, and endure, they remind us that the future of space isn't just about reaching new frontiers, it's about creating them. Mining the moon is no walk in the park. It's more like a high-stakes survival mission in one of the most hostile environments imaginable. Picture a world where temperatures can swing from 270 degrees Fahrenheit during the day to minus 280 degrees at night. That's not just extreme, it's a nightmare for any machine trying to operate there. And if that weren't enough, the moon has no atmosphere to shield against radiation or micrometeoroids, meaning robots are constantly exposed to hazards that could fry circuits or puncture vital systems. Then there's the dust, not your average dust, but a fine, abrasive powder that clings to everything, grinding away at surfaces and clogging moving parts. It's like trying to work in a sandstorm made of razor blades. So, how do engineers tackle these challenges? The answer lies in innovation and resilience. To combat the brutal temperature swings, robots are built with advanced thermal management systems. Some use reflective coatings to deflect the sun's intense heat during the day, while others rely on insulation and heaters to stay operational during the frigid lunar nights. Think of it as a high-tech winter coat combined with a cooling system, all designed to keep the delicate electronics inside running smoothly. Then there's the problem of lunar dust. This isn't just an annoyance, it's a serious threat to machinery. To address this, engineers have developed dust-proof seals and specialized materials that resist abrasion. Some robots even use electrostatic systems to repel dust particles, keeping critical components clean and functional. It's a bit like giving a robot an invisible shield, one that keeps the relentless lunar grime at bay. But perhaps the most ingenious solutions come in the form of modular design. Instead of building robots that can handle every possible scenario, engineers create machines that can adapt and even repair themselves. For example, if a component fails due to radiation or dust, the robot can swap it out for a spare or reconfigure its systems to keep working. This adaptability is key to surviving the moon's unyielding conditions, turning potential disasters into manageable setbacks. The harshness of the lunar environment isn't just a challenge, it's a proving ground. Every robot sent to the moon is a test of human ingenuity, pushing the boundaries of what's possible in extreme conditions. And as these machines learn to thrive where no human could, they're not just mining resources, they're paving the way for a future where the moon becomes a sustainable outpost for exploration and discovery. This is the reality of moon mining, a delicate dance between cutting-edge technology and the unforgiving forces of nature. But with every obstacle overcome, we're one step closer to unlocking the moon's potential and taking humanity's next giant leap into the cosmos. One of the most fascinating challenges of moon mining isn't just about surviving the harsh environment, it's about overcoming the vast distance between Earth and our lunar neighbor. When you're dealing with a delay of nearly 3 seconds for signals to travel from Earth to the moon and back, real-time control of robots becomes impossible. Imagine trying to steer a rover through a field of boulders with a lag of several seconds between your command and its action. It's like trying to play a video game with a bad internet connection, except the stakes are much higher. This is where autonomy becomes not just a luxury, but a lifeline. AI-powered robots on the moon are designed to think for themselves, making split-second decisions without waiting for instructions from mission control. These machines are equipped with sophisticated algorithms that allow them to analyze their surroundings, assess risks, and choose the best course of action. For example, if a robot encounters a steep crater or an unstable rock formation, Its AI can instantly evaluate the situation and determine whether to proceed, reroute, or even pause and wait for better conditions. But autonomy doesn't stop at navigation. These robots are also programmed to handle complex tasks like drilling, sampling, and even repairing themselves. Take the process of extracting water ice from a shadowed crater. The robot must first identify the optimal spot to drill, then carefully extract the ice without contaminating the sample. All of this requires precise coordination and decision-making, all handled by the robot's onboard AI. It's like having a scientist and an engineer rolled into one, working tirelessly on the moon's surface. What makes this even more remarkable is the role of machine learning. Over time, these robots don't just follow pre-programmed instructions, they learn from their experiences. Every task they complete, every obstacle they overcome, adds to their knowledge base, allowing them to adapt and improve. For instance, if a robot encounters a new type of terrain, it can analyze the data, adjust its approach, and store that information for future missions. This continuous learning process ensures that each robot becomes more efficient and capable with every lunar day. Of course, building such autonomous systems is no small feat. Engineers must account for countless variables, from the unpredictable lunar terrain to the limited power and computing resources available on the moon. The result is a delicate balance between precision and flexibility, where robots must be smart enough to handle unexpected challenges, but efficient enough to conserve energy and avoid errors. Autonomy isn't just a technical achievement, it's a game changer for lunar exploration. It allows us to extend our reach beyond the limits of human control, enabling machines to explore, analyze, and even prepare the moon for future human missions. And as these robots grow smarter and more capable, they're not just mining resources, they're laying the foundation for a sustainable presence on the moon, one decision at a time. This blend of autonomy and machine learning is what makes lunar mining possible in such a remote and unforgiving environment. It's a testament to human ingenuity, proving that even in the face of immense challenges, we can create systems that think, adapt, and thrive. And as these robots continue to push the boundaries of what's possible, they're not just shaping the future of moon mining, they're redefining how we explore the cosmos. Extracting resources from the moon is a monumental achievement, but the real magic happens when those raw materials are transformed into something usable. Think of it like this: finding a vein of gold is exciting, but it's the process of refining that gold into a gleaming, valuable resource that truly matters. On the moon, the challenges of resource processing are amplified by the very environment that makes these resources so valuable. Take water ice, for example. While its discovery in shadowed craters is a game changer, turning that ice into drinkable water or rocket fuel is no simple task. The process begins with extraction, where robots drill or scoop the ice from the lunar surface. But then comes the tricky part: melting and purifying the ice in a place where temperatures can plummet to hundreds of degrees below zero. Engineers are developing specialized heating systems and filtration units that can operate in these extreme conditions, ensuring that the water is clean and ready for use. It's like building a high-tech water treatment plant on the moon. Then there's the challenge of extracting metals and rare earth elements from lunar soil, known as regolith. Unlike Earth, where we have vast mining operations and industrial facilities, the moon offers no such infrastructure. Instead, robots must process the regolith on site, using techniques like electrochemical separation or molten salt electrolysis to isolate valuable metals. These methods aren't just about breaking rocks, they're about precision, requiring AI to monitor and adjust the process in real time to maximize efficiency and minimize waste. This is where artificial intelligence truly shines. Imagine a system that can analyze the composition of lunar soil, determine the optimal extraction method, and then fine-tune the process based on real-time data. AI doesn't just make these tasks possible, it makes them smarter. For instance, if a robot detects a higher concentration of a particular metal in one area, its AI can adjust the extraction parameters to focus on that material, ensuring nothing goes to waste. It's like having an expert chemist and engineer working together, but in the form of algorithms and sensors. But efficiency isn't the only concern. The moon's limited resources mean that every step of the process must be as sustainable as possible. AI helps here too, optimizing energy use and recycling byproducts to create a closed-loop system. For example, waste heat from one process could be used to power another, or leftover materials could be repurposed for construction or manufacturing. This isn't just about getting the job done, it's about doing it responsibly with an eye toward long-term sustainability. What's truly remarkable is how these technologies are being designed to work together, creating a seamless pipeline from extraction to processing. Robots equipped with AI don't just collect and refine resources, they learn from each task, improving their methods over time. This continuous evolution means that every mission brings us closer to a future where lunar resources are not just accessible, but fully integrated into our technological and industrial systems. The moon's resources are undeniably valuable, but their true potential lies in our ability to transform them into something practical and impactful. From water to metals, every step of the process is a testament to human ingenuity and the power of AI. And as we refine these technologies, we're not just unlocking the moon's riches, we're building the foundation for a sustainable, resourceful future, both on Earth and beyond. As moon mining transitions from science fiction to reality, it brings with it a complex web of ethical and legal questions that demand our attention. Who, for instance, has the right to extract and profit from the moon's resources? Is it the first nation or company to land there? Or does the moon belong to all of humanity, a shared heritage that no single entity can claim? These aren't just philosophical musings, they're urgent issues that will shape the future of lunar exploration and resource utilization. The legal framework for lunar activities is rooted in the Outer Space Treaty of 1967, a landmark agreement signed by over 100 countries. This treaty establishes that outer space, including the moon, is the province of all mankind and cannot be claimed by any nation. While this sounds straightforward, it leaves a lot of room for interpretation. For example, while countries can't claim sovereignty over the moon, the treaty doesn't explicitly prohibit the extraction and use of its resources. This ambiguity has sparked heated debates, with some nations and private companies pushing for clearer guidelines on how lunar resources can be exploited. In recent years, countries like the United States have taken steps to address this grey area. The Artemis Accords, a set of principles introduced by NASA, aim to create a framework for international cooperation in lunar exploration. These accords encourage transparency, sustainability, and the peaceful use of space resources. They also allow nations to establish safety zones around their lunar activities, ensuring that operations don't interfere with others. While the accords have been welcomed by some, others argue that they risk creating a de facto system of ownership, undermining the spirit of the Outer Space Treaty. Beyond the legal debates, there are profound ethical considerations. The moon's resources are finite, and how we choose to use them will have lasting consequences. Should we prioritize commercial interests or focus on scientific research and the greater good? What about the potential environmental impact of mining on the moon's fragile ecosystem, if it can even be called that? And how do we ensure that the benefits of lunar resources are shared equitably, rather than being monopolized by a handful of wealthy nations or corporations? These are questions that require careful thought and global collaboration. One promising approach is to treat the moon as a global commons, where resources are managed collectively for the benefit of all humanity. This could involve creating international oversight bodies to regulate lunar activities, ensuring that mining operations are conducted responsibly and sustainably. It might also include mechanisms for sharing the profits or technological advancements derived from lunar resources, helping to bridge the gap between developed and developing nations. Ultimately, the moon is more than just a source of materials. It's a symbol of what humanity can achieve when we work together. As we stand on the brink of this new frontier, we have a unique opportunity to set a precedent for how we explore and utilize space. Will we approach it with greed and competition, or with cooperation and foresight? The choices we make today will echo far into the future, shaping not just the destiny of the moon, but of humanity itself. This isn't just about mining rocks or extracting water. It's about defining the values we carry with us as we reach for the stars. And in doing so, we have the chance to create a legacy that reflects the best of what humanity can be. As we venture into the realm of moon mining, there's a question that looms larger than any technical hurdle. What happens to the moon itself? While it may seem like a barren, lifeless world, the moon is far from inert. Its surface, shaped by billions of years of cosmic activity, holds a delicate balance that human intervention could disrupt. Mining operations, no matter how carefully planned, have the potential to alter its landscape, disturb its regolith, and even impact its gravitational stability. Unlike Earth, where ecosystems can recover over time, the moon's environment is fragile and slow to change. Once disrupted, it might never return to its original state. One of the primary concerns is the physical impact of mining. Extracting resources like water, ice, or metals requires digging, drilling, and moving large amounts of lunar soil. This activity could create dust clouds that linger in the moon's low gravity, potentially interfering with equipment or even future missions. Worse, the removal of materials could destabilize the moon's surface, leading to shifts in its crust or changes in its gravitational field. These changes might seem minor, but on a celestial body with no active geological processes to repair itself, even small disturbances could have lasting effects. Then there's the question of contamination. The moon's pristine environment offers a unique window into the history of our solar system. Its untouched regolith holds clues about the formation of planets, the impact of ancient asteroids, and even the origins of life on Earth. Introducing human-made chemicals, machinery, or waste could compromise these scientific treasures, erasing information that's been preserved for billions of years. It's a bit like walking into an ancient library and accidentally spilling ink on priceless manuscripts. Some knowledge, once lost, can never be recovered. But scientists and engineers aren't taking these risks lightly. Efforts are already underway to develop mining techniques that minimize environmental impact. For example, some proposals suggest using enclosed systems to extract water ice, preventing dust from spreading into the surrounding area. Others focus on precision, drilling, targeting specific deposits with minimal disturbance to the lunar surface. There's even research into green mining methods that recycle waste materials or use solar energy to power operations, reducing the need for harmful byproducts. Balancing resource extraction with environmental preservation isn't just a technical challenge, it's a moral one. The moon is more than a collection of rocks and minerals. It's a symbol of wonder and exploration, a place that has inspired humanity for millennia. Preserving its natural state, even as we seek to harness its resources, is a responsibility we can't afford to ignore. After all, the moon isn't just a stepping stone for our ambitions, it's a legacy we're leaving for future generations, both on Earth and beyond. By approaching lunar mining with care and foresight, we can ensure that our actions today don't compromise the moon's integrity tomorrow. It's a delicate balance, but one that reflects the best of human ingenuity, the ability to dream big while respecting the world, and worlds we call home. Now, let's tackle one of the most critical questions surrounding moon mining. Is it economically viable? After all, the promise of lunar resources is undeniably exciting, but it means little if the costs outweigh the benefits. Developing the technology and infrastructure needed to extract and process materials on the moon requires staggering investments, billions of dollars, years of research, and countless hours of engineering ingenuity. So, is this endeavor worth the price tag? Let's break it down. First, consider the sheer cost of getting to the moon. Launching missions isn't just about building rockets, it's about creating robust spacecraft, advanced robotics, and sustainable systems that can survive the journey and operate effectively in a hostile environment. Each launch can cost hundreds of millions of dollars, and that's before factoring in the expenses of developing mining equipment, processing units, and the AI systems that power them. It's a financial mountain that only the most ambitious organizations are willing to climb, but here's where things get interesting. While the upfront costs are undeniably high, the potential returns could be game-changing. Take water ice, for example. If we can extract and process it into hydrogen and oxygen for rocket fuel, the moon could serve as a refueling station for deep space missions. Instead of hauling fuel from Earth, a massively expensive and inefficient process, we could tap into lunar resources, drastically reducing the cost of exploration. This alone could make moon mining a worthwhile investment, not just for governments but for private companies looking to capitalize on the emerging space economy. Then there's the value of rare materials like helium-3 and rare earth metals. These resources are in high demand on Earth, but their scarcity and the environmental impact of terrestrial mining make them increasingly difficult to access. The moon offers a new frontier for extraction, potentially stabilizing supply chains and driving down costs. If we can develop efficient methods to mine and transport these materials, the financial rewards could be immense. Of course, none of this happens in a vacuum. Governments and private companies are already collaborating to share the risks and rewards of lunar mining. NASA's Artemis program, for instance, is working with commercial partners to develop the infrastructure needed for sustained lunar exploration. Similarly, private space companies are investing heavily in technologies that could turn the moon into a profitable venture. These partnerships are key to making moon mining economically feasible, combining public funding with private innovation to push the boundaries of what's possible. But economics isn't just about dollars and cents, it's about long-term vision. The moon isn't just a source of resources, it's a proving ground for technologies and strategies that could shape humanity's future in space. Every dollar spent on lunar exploration is an investment in our ability to explore farther, live sustainably, and unlock the potential of the cosmos. So, is moon mining worth the cost? The answer isn't just about immediate profit, it's about the opportunities it creates, the challenges it overcomes, and the future it enables. As we weigh the risks and rewards, one thing is clear: the moon isn't just a destination, it's a stepping stone to something much bigger. The moon doesn't belong to any one nation or company. It's a celestial body that has captivated humanity for millennia. Yet, as we enter the era of lunar mining, the question of how we share this vast, untapped resource becomes increasingly urgent. Across the globe, nations and private companies are racing to stake their claim, creating a complex mix of collaboration and competition that could define the future of space exploration. This isn't just about who gets to mine the moon, it's about how we work together, or fail to, in the face of unprecedented opportunity. At first glance, the idea of international collaboration seems like the obvious path forward. After all, the moon is a shared resource, and pooling resources, knowledge, and technology could accelerate progress for everyone. Programs like NASA's Artemis Accords are a step in this direction, fostering partnerships between nations and encouraging transparency in lunar activities. Countries like the United States, Japan, Canada, and several European nations have already signed on, committing to principles of peaceful cooperation and sustainable exploration. These alliances aren't just symbolic, they're practical, allowing nations to share the immense costs and risks of lunar missions while reaping the rewards collectively. But collaboration isn't the only force at play. Competition is equally powerful, and it's driving innovation at a breakneck pace. Private companies like SpaceX, Blue Origin, and smaller startups are entering the fray, each bringing their own vision for lunar resource extraction. These companies aren't just building rockets, they're developing cutting-edge technologies, from advanced drilling systems to AI-driven processing units, that could make moon mining more efficient and profitable. For some, the moon represents a lucrative business opportunity, with the potential to supply Earth with rare materials or fuel future space missions. For others, it's a chance to cement their place in the emerging space economy. This blend of collaboration and competition creates a unique dynamic. On one hand, partnerships between governments and private entities are essential for overcoming the technical and financial challenges of lunar mining. On the other hand, the race to secure resources and establish dominance could lead to tensions, especially as the stakes grow higher. Nations like China and Russia, for instance, are pursuing their own lunar ambitions, sometimes outside the framework of international agreements. This raises important questions about how we'll navigate the competing interests of global players while ensuring that the moon remains a shared resource, not a battleground. What's at stake here isn't just the moon's resources, it's the future of how humanity operates in space. Will we approach this new frontier with a spirit of cooperation, pooling our collective knowledge and resources for the greater good? Or will competition and self-interest lead to fragmentation, with nations and companies carving up the moon for their own benefit? The answer will shape not just lunar mining, but the broader trajectory of space exploration. One thing is certain, the moon is too big for any one entity to conquer alone. Whether through collaboration or competition, the path forward will require balancing ambition with responsibility, innovation with ethics, and self-interest with the common good. As we stand on the brink of this new era, the choices we make today will echo far beyond the moon, setting the tone for humanity's future in space. This isn't just a race to the moon, it's a test of our ability to unite as a global community, even as we reach for the stars. And in that challenge lies an opportunity to redefine what it means to explore, not just as nations or companies, but as a species. The moon may be silent, but its story is far from over, and the next chapter is ours to write. One of the most exciting aspects of moon mining isn't just what we're extracting, it's how we're doing it. The challenges of operating in such a harsh and unpredictable environment are driving a wave of technological breakthroughs that could revolutionize not just space exploration, but life back on Earth. From robots that can repair themselves to habitats built with lunar materials, the moon is becoming a proving ground for some of the most advanced technologies ever conceived. Take self-repairing robots, for example. On Earth, if a machine breaks down, you can call in a technician to fix it. But on the moon, where help is millions of miles away, robots need to be able to handle their own maintenance. Engineers are developing systems that allow robots to detect damage, diagnose the problem, and even replace faulty components, all without human intervention. This isn't just about convenience, it's about survival. A robot that can adapt and recover from malfunctions is far more likely to succeed in the moon's unforgiving environment, ensuring that missions stay on track even when things go wrong. Then there's the rise of 3D printing, a technology that's finding extraordinary applications on the moon. Imagine a construction system that uses lunar soil, or regolith, as raw material to build habitats, landing pads, or even roads. Instead of shipping heavy building materials from Earth, which is incredibly costly, we could use the moon's own resources to create structures on site. These 3D printed habitats wouldn't just be functional, they'd be tailor-made for the lunar environment, designed to withstand radiation, micrometeoroid impacts, and extreme temperature swings. It's a game changer for sustainable living in space, and it's already being tested in prototype form. But the innovations don't stop there. Moon mining is also pushing the boundaries of artificial intelligence. The robots we send to the moon aren't just following pre-programmed instructions, they're learning as they go. Advanced AI systems are enabling these machines to analyze their surroundings, make decisions, and even predict potential issues before they arise. For instance, an AI-powered robot might detect a slight vibration in its drill and adjust its operation to avoid a breakdown. This level of intelligence isn't just about efficiency, it's about resilience, allowing robots to navigate the moon's unpredictable terrain with confidence and precision. Energy is another area where moon mining is driving innovation. Solar power is the obvious choice for lunar operations, but the moon's two long nights pose a significant challenge. To address this, scientists are exploring alternative energy sources, such as small nuclear reactors or energy storage systems that can keep operations running during the long lunar night. These technologies aren't just useful for the moon, they could also transform how we generate and store energy on Earth, offering new solutions for clean, sustainable power. What's truly remarkable is how these advancements are interconnected. A self-repairing robot might rely on AI to diagnose a problem, 3D printing to replace a part, and advanced energy systems to keep running. Each innovation builds on the others, creating a network of technologies that work together to overcome the challenges of lunar mining. And as these technologies evolve, they're not just solving problems on the moon, they're opening up new possibilities for humanity's future in space. The moon isn't just a destination, it's a catalyst, pushing us to think bigger, work smarter, and innovate faster. Every breakthrough we make there has the potential to ripple back to Earth, transforming industries, solving global challenges, and redefining what's possible. So, while we may be mining the moon for its resources, we're also mining it for something far more valuable: the inspiration and ingenuity to take humanity's next giant leap. While AI-powered robots are the stars of moon mining, they don't work alone. Behind every autonomous machine is a team of humans, engineers, scientists, and astronauts who make these missions possible. It's a partnership that blends the precision of artificial intelligence with the creativity and problem-solving skills of human minds. Together, they're unlocking the moon's potential in ways neither could achieve alone. On Earth, engineers and scientists are the unsung heroes of lunar mining. They design the robots, write the algorithms, and monitor every move from mission control. Picture a room filled with screens, each displaying real-time data from the moon temperature readings, energy levels, even the robot's internal diagnostics. These experts analyze the information, troubleshoot issues, and make adjustments to ensure everything runs smoothly. It's like conducting an orchestra where every note must be perfect, even when the musicians are millions of miles away. But the human role doesn't stop at Earth. As we look to the future, astronauts are poised to play an even bigger part in lunar mining. Imagine a team of explorers living and working on the moon, supervising robots and conducting hands-on experiments. These astronauts won't just be observers, they'll be active participants, using their training and ingenuity to solve problems that robots can't handle. For instance, if a robot encounters an obstacle it can't navigate, an astronaut could step in to guide it or even perform repairs. It's a dynamic partnership where humans and machines complement each other's strengths. This collaboration extends to remote operation as well. With advancements in communication technology, astronauts on the moon could control robots in real time, even from a distance. Think of it as a high-stakes video game where the stakes are real and the consequences are monumental. A single command could mean the difference between a successful mission and a costly failure. This level of human oversight ensures that even the most autonomous systems have a safety net, combining the best of both worlds, machine efficiency and human intuition. Of course, sending humans to the moon isn't just about mining, it's about building a sustainable presence. Astronauts will need habitats, life support systems, and infrastructure to survive and thrive. These structures could be constructed using lunar materials, creating a self-sustaining ecosystem that supports both human and robotic operations. It's a vision of the future where the moon isn't just a source of resources, but a hub of activity and innovation. The synergy between humans and robots is what makes moon mining truly groundbreaking. Robots handle the repetitive, dangerous tasks, while humans bring creativity, adaptability, and a deep understanding of complex systems. Together, they're pushing the boundaries of what's possible, transforming the moon from a distant dream into a tangible reality. This human-robot partnership isn't just about technology, it's about teamwork. It's a reminder that even in the age of artificial intelligence, there's no substitute for human ingenuity. And as we explore this new frontier, we're not just unlocking the moon's resources, we're discovering what we're capable of when we work together, both on Earth and beyond. As we look to the moon for its vast resources, one question rises above the rest. How do we ensure that lunar mining is sustainable? This isn't just about extracting water, ice, or rare metals. It's about doing so in a way that preserves the moon's delicate environment while creating a model for responsible resource use across the solar system. The moon may seem barren, but it's not immune to the consequences of human activity. Mining operations, if not carefully managed, could leave lasting scars on its surface, disrupt its fragile equilibrium, and even jeopardize future missions. To tackle this challenge, scientists and engineers are rethinking every aspect of lunar resource extraction. One key strategy is the development of closed-loop systems, where waste from one process becomes the raw material for another. For example, the dust and debris generated during mining could be repurposed to create building materials or even used in 3D printing. This approach not only minimizes waste, but also reduces the need to transport additional resources from Earth, cutting costs and lowering the environmental impact. Energy is another critical factor in sustainable mining. Solar power is the most obvious choice for lunar operations, but the moon's two-wee, long nights present a significant hurdle. To address this, researchers are exploring innovative solutions like energy storage systems and small-scale nuclear reactors that could provide a steady power supply even during the long lunar night. These technologies aren't just about keeping the lights on, they are about ensuring that mining operations can run efficiently and sustainably over the long term. But sustainability isn't just about technology, it's also about planning. Before any mining begins, detailed surveys and environmental assessments are conducted to identify the most suitable locations and methods. This careful planning helps minimize disruption to the lunar surface and ensures that valuable scientific sites, like ancient craters or unique geological formations, remain untouched. It's a bit like urban planning, but on a cosmic scale, where every decision has far-reaching implications. What makes these efforts even more exciting is their potential to inspire sustainable practices back on Earth. The challenges of mining on the moon, limited resources, harsh conditions, and the need for efficiency mirror many of the issues we face here at home. By developing solutions for the moon, we're also creating tools and strategies that could help address problems like resource scarcity, pollution, and energy inefficiency on Earth. It's a two-way street where innovations from space exploration drive progress on our own planet. Perhaps the most profound aspect of sustainable lunar mining is the mindset it represents. The moon is teaching us to think differently about resource use, to see waste as a potential resource, to prioritize efficiency over exploitation, and to consider the long-term impact of our actions. These lessons aren't just valuable for space exploration, they're essential for building a sustainable future, whether we're on Earth, the moon, or beyond. By approaching the moon with care and foresight, we're not just mining resources, we're creating a blueprint for how humanity can thrive in harmony with its environment. It's a vision of sustainability that stretches across the stars, reminding us that even in the vastness of space, every action has a consequence. And as we take these first steps, we're not just shaping the future of the moon, we're shaping the future of our species. The rise of private companies in the realm of moon mining marks a seismic shift in how we approach space exploration. No longer the exclusive domain of government space agencies, the moon is now a frontier where innovation meets ambition, driven by the vision and resources of the private sector. Companies like SpaceX, Blue Origin, and a host of emerging startups are not just participating in lunar exploration, they're redefining it. Take SpaceX, for instance. Known for its groundbreaking work in reusable rockets, the company is already laying the groundwork for lunar missions with its Starship spacecraft. But SpaceX's ambitions go far beyond just getting to the moon. They're exploring ways to extract and utilize lunar resources, from water ice to metals, to support long-term missions and even settlements. Their approach is bold, fast-paced, and unapologetically entrepreneurial, embodying the spirit of private enterprise in space. Blue Origin, founded by Jeff Bezos, is equally ambitious. The company's Blue Moon lander is designed to deliver payloads, equipment, and potentially even humans to the lunar surface. Blue Origin's vision extends beyond resource extraction. They're focused on creating a sustainable lunar infrastructure that could support everything from mining operations to scientific research. Their emphasis on sustainability and long-term planning sets them apart, offering a different but equally compelling approach to lunar exploration. But it's not just the big names driving this shift. A growing number of smaller companies are entering the space, each bringing unique ideas and technologies to the table. Startups like Astrobotic and iSpace are developing lunar landers and rovers, while others are focusing on specialized equipment for mining and processing lunar resources. These companies are nimble, innovative, and unafraid to take risks, injecting fresh energy into the field and pushing the boundaries of what's possible. The private sector's involvement brings undeniable benefits. For one, it accelerates innovation. Companies are often more agile than government agencies, able to pivot quickly and experiment with new ideas. They're also willing to invest heavily in cutting-edge technologies, from AI-driven robots to advanced extraction methods, that could make moon mining more efficient and cost-effective. This influx of capital and creativity is driving progress at an unprecedented pace, turning what once seemed like science fiction into tangible reality. However, this shift isn't without its challenges. Privatizing space exploration raises important questions about accountability and equity. Who ensures that lunar resources are mined responsibly without causing irreparable harm to the moon's environment? How do we prevent a scenario where only the wealthiest nations or corporations benefit from these resources, leaving others behind? These are complex issues that require careful consideration and international cooperation. Another concern is the potential for competition to escalate into conflict. As more companies enter the lunar mining race, the risk of overlapping claims or disputes over resource-rich areas grows. Without clear regulations and oversight, the moon could become a new battleground for economic and geopolitical rivalries. Striking the right balance between competition and collaboration will be crucial to ensuring that lunar exploration benefits all of humanity, not just a select few. Despite these challenges, the private sector's involvement in moon mining is undeniably transformative. It's bringing new energy, new ideas, and new possibilities to the table, accelerating our progress toward a future where the moon is a thriving hub of activity. But as we embrace this new era, we must also navigate its complexities with care, ensuring that the moon remains a shared resource and a symbol of what humanity can achieve when we work together. This isn't just about mining rocks or extracting water, it's about shaping the future of space exploration. And as private companies take center stage, they're not just changing how we explore the moon, they're redefining what it means to reach for the stars. As we stand on the cusp of a new era, the future of moon mining is poised to reshape not just space exploration, but life here on Earth. Over the next decade, the vision of large-scale lunar resource extraction could become a reality, unlocking possibilities that were once confined to the realm of science fiction. But what will this future look like, and what will it take to get there? Let's take a closer look at the road ahead. One of the most exciting prospects is the establishment of permanent lunar bases. These wouldn't just be research outposts, they'd be fully operational hubs for mining, processing, and even manufacturing. Picture a bustling lunar colony where robots and humans work side by side, extracting water ice to produce rocket fuel, refining metals for construction, and building infrastructure to support deeper space missions. These bases could serve as the backbone of a lunar economy, turning the moon into a self-sustaining resource hub that fuels humanity's expansion into the solar system. But to make this vision a reality, we'll need breakthroughs in technology and infrastructure. Advanced robotics and AI will play a central role, with machines capable of handling increasingly complex tasks autonomously. Imagine fleets of robots working in unison, digging trenches, assembling structures, and even repairing each other without human intervention. These systems won't just be efficient, they'll be resilient, designed to adapt to the moon's unpredictable challenges and keep operations running smoothly. Energy will also be a critical factor. Solar power will remain a cornerstone, but we'll need innovative solutions to overcome the moon's long nights. One possibility is the development of compact nuclear reactors that can provide a steady, reliable power source. These reactors could power everything from mining operations to life support systems, ensuring that lunar bases remain functional even during the 2-week-long lunar night. It's a challenge, but one that could pave the way for sustainable energy solutions both on the moon and back on Earth. Partnerships will be equally important. No single nation or company can tackle the immense challenges of lunar mining alone. We'll need global collaboration, with governments, private companies, and research institutions pooling their resources and expertise. Programs like NASA's Artemis Accords are already laying the groundwork for this kind of cooperation, but the future will demand even greater unity. By working together, we can share the risks, reduce costs, and accelerate progress, ensuring that the benefits of lunar mining are felt by all of humanity. And then there's the bigger picture. The moon is just the beginning. The technologies and strategies we develop there will serve as a blueprint for exploring and exploiting resources on other celestial bodies, from Mars to the asteroids. Imagine a future where lunar mining techniques are adapted to extract water from Mars ice caps or harvest precious metals from asteroids. The possibilities are endless, and the moon is the perfect testing ground to make them a reality. But perhaps the most profound impact of moon mining won't be felt in space, it'll be felt right here on Earth. By learning to extract and process resources sustainably on the moon, we'll gain valuable insights into how to manage Earth's own resources more responsibly. The lessons we learn from lunar mining could revolutionize industries, reduce environmental impact, and help us build a more sustainable future for our planet. The future of moon mining is more than just a technical challenge, it's a story of human ambition, ingenuity, and collaboration. As we look ahead to the next decade and beyond, one thing is clear: the moon isn't just a destination. It's a stepping stone to a future where humanity thrives not just on Earth, but among the stars. And as we take these next steps, we're not just shaping the future of the moon, we're shaping the future of our species. This is the promise of moon mining, a chance to explore, innovate, and dream on a scale we've never imagined. And as we turn this vision into reality, we're not just reaching for the stars, we're bringing them within reach. The role of artificial intelligence in space exploration goes far beyond the moon. It's reshaping how we explore the entire cosmos. While AI-powered robots are making lunar mining possible, their impact extends to missions across the solar system, from the dusty plains of Mars to the rocky surfaces of distant asteroids. These machines aren't just tools, they're the backbone of a new era in space exploration, enabling us to venture farther and faster than ever before. Take Mars, for example. The red planet has long been a target for human exploration, but its harsh environment and vast distance from Earth make it a daunting challenge. Here's where AI comes in. Rovers like NASA's Perseverance rely on advanced AI systems to navigate the planet's rugged terrain, analyze geological features, and even select samples for collection. These robots don't just follow pre-programmed instructions, they make real-time decisions, adapting to unexpected obstacles and optimizing their operations. It's a level of autonomy that's crucial for missions where communication delays can stretch to 20 minutes or more, but AI's potential doesn't stop at Mars. Consider asteroid mining, a field that's gaining traction as a way to access valuable resources like platinum, nickel, and water. Asteroids are incredibly challenging targets. They're small, fast-moving, and often located in remote parts of the solar system. Mining them requires precision and adaptability, which is exactly what AI-powered robots can provide. Imagine a spacecraft equipped with AI navigating to an asteroid, analyzing its composition, and extracting resources with surgical precision, all without human intervention. This isn't just science fiction, it's a vision that's quickly becoming reality thanks to the lessons we're learning from moon mining. What's truly fascinating is how these technologies are interconnected. The AI systems developed for lunar mining are being adapted for use in other missions, creating a feedback loop of innovation. For instance, the algorithms that help a robot navigate the moon's craters could also guide a rover on Mars or steer a spacecraft toward an asteroid. This cross-pollination of ideas is accelerating progress, allowing us to tackle challenges that once seemed insurmountable. AI is also transforming how we plan and execute missions. Traditionally, space exploration has relied on meticulous step-by-step planning, with every detail mapped out in advance. But as missions become more complex and ambitious, this approach is reaching its limits. AI offers a solution by enabling dynamic, real-time decision-making. Instead of sticking rigidly to a plan, AI systems can adapt to changing conditions, prioritize tasks, and even predict potential problems before they arise. This flexibility is a game-changer, allowing us to explore more efficiently and effectively. The lessons we're learning from moon mining are proving invaluable for these broader applications. By perfecting AI-driven resource extraction on the moon, we're developing the tools and techniques needed to mine asteroids, explore Mars, and beyond. These technologies aren't just about extracting resources, they're about expanding our understanding of the universe and unlocking its potential. As we look to the future, one thing is clear: AI is the key to unlocking the cosmos. It's not just a tool for solving specific problems, it's a catalyst for innovation, enabling us to dream bigger and reach farther. Whether we're exploring the moon, Mars, or the farthest reaches of the solar system, AI is the common thread that ties it all together. And as we continue to push the boundaries of what's possible, we're not just exploring space, we're redefining what it means to be explorers. This is the promise of AI in space exploration, a future where the stars are within reach and the universe is ours to discover. And as we take these next steps, we're not just shaping the future of space, we're shaping the future of humanity. While the moon may seem like a distant frontier, its impact could be felt much closer to home, right here on Earth. Moon mining isn't just about exploring space, it's about reshaping the global economy in ways we're only beginning to understand. From rare metals to clean energy, the resources extracted from the moon have the potential to create new industries, disrupt existing ones, and even redefine how we think about economic growth. But with these opportunities come challenges, and navigating this new resource economy will require careful planning and foresight. Let's start with rare earth metals, a group of elements essential for everything from smartphones to electric vehicles. On Earth, these materials are becoming increasingly difficult to mine due to environmental concerns and geopolitical tensions. The moon, however, offers a vast reservoir of these metals, potentially easing the strain on terrestrial supplies and stabilizing global markets. By tapping into lunar resources, we could reduce our reliance on conflict zones and environmentally damaging mining practices, creating a more sustainable and ethical supply chain. But this shift isn't without risks. For countries and industries heavily invested in terrestrial mining, the rise of lunar resources could pose economic challenges, forcing them to adapt or risk being left behind. Energy is another area where moon mining could have a profound impact. Helium-3, a rare isotope abundant on the moon, holds the promise of revolutionizing nuclear fusion. If harnessed, this clean, nearly limitless energy source could transform how we power our homes, industries, and transportation systems. Imagine a world where energy is no longer tied to fossil fuels or limited by environmental concerns. A world powered by the moon. This could spark a new era of economic growth, creating jobs, driving innovation, and reducing the global carbon footprint. But it also raises questions about who will control this energy revolution and how its benefits will be distributed. Beyond these specific industries, moon mining could catalyze the growth of entirely new sectors. From space tourism to lunar manufacturing, the possibilities are vast. Companies could emerge to provide services like lunar logistics, resource processing, or even lunar real estate development. These new industries could generate billions of dollars in revenue, create thousands of jobs, and drive technological advancements that ripple across the global economy. But as with any economic shift, there's a risk of creating winners and losers. How do we ensure that the benefits of this new space economy are shared equitably, rather than concentrated in the hands of a few powerful entities? Managing this new resource economy will be no small feat. Governments, corporations, and international organizations will need to work together to establish fair regulations, prevent monopolies, and address potential conflicts over resource rights. The moon could become a testing ground for new economic models, where sustainability and cooperation are prioritized over exploitation and competition. This isn't just about economics, it's about creating a framework for how humanity can responsibly share and benefit from the resources of space. The moon's potential to transform Earth's economy is undeniable. But realizing this potential will require more than just technological innovation. It will demand vision, collaboration, and a commitment to building a future that benefits everyone. As we look to the stars, we're reminded that the choices we make today will shape not just the moon's destiny, but our own. And in that challenge lies an extraordinary opportunity to create an economy that's not just prosperous, but fair, sustainable, and truly out of this world. As moon mining transitions from science fiction to reality, one of the most pressing challenges isn't just technological or economic, it's educational. How do we ensure that the public understands the significance of this groundbreaking endeavor? How do we inspire the next generation to dream big and take part in shaping humanity's future in space? The answer lies in education and awareness, turning the moon into not just a resource hub, but a classroom for the future. Schools and universities are already stepping up to the plate, integrating space exploration and lunar mining into their curricula. Imagine a high school physics class where students design their own lunar rovers, or a university engineering program focused on developing sustainable mining technologies for the moon. These programs aren't just about teaching facts, they're about igniting curiosity and fostering creativity. By giving students hands-on experience with real-world space challenges, educators are preparing them to become the scientists, engineers, and explorers of tomorrow. But education isn't confined to classrooms. Museums, science centers, and public outreach programs are playing a vital role in raising awareness about moon mining. Exhibits showcasing lunar soil samples, interactive displays explaining the science of resource extraction, and even virtual reality experiences that let visitors walk on the moon are bringing this distant world closer to home. These initiatives make space accessible to everyone, not just those with a background in science or engineering, helping to demystify the complexities of lunar exploration and sparking a sense of wonder in people of all ages. The media also has a crucial part to play. Documentaries, podcasts, and news coverage are bringing the story of moon mining to life, highlighting both its potential and its challenges. By presenting balanced, well-researched narratives, journalists and content creators are helping the public understand why this endeavor matters and what's at stake. It's not just about the science, it's about the bigger picture, how lunar resources could transform life on Earth, and what it means for humanity's place in the cosmos. Perhaps most importantly, Inspiring the next generation is about more than just knowledge, it's about vision. Programs like NAS, our Artemis student challenges and international space competitions are giving young people a chance to contribute to real-world missions. Imagine a teenager designing a tool for lunar mining or a college student proposing a new method for extracting water ice. These opportunities don't just build skills, they build confidence, showing young minds that their ideas can shape the future. The moon is more than a destination, it's a symbol of what we can achieve when we dream big and work together. By investing in education and public awareness, we're not just preparing for a future of lunar mining, we're creating a culture of curiosity, innovation, and collaboration. And as we inspire the next generation to reach for the stars, we're ensuring that the moon's story isn't just about resources, it's about the people who will unlock its potential and carry humanity's dreams forward. This is the power of education, to transform the unknown into the possible and to turn distant horizons into stepping stones for growth. And as we look to the moon, we're reminded that the greatest resource we have isn't buried in its soil, it's the boundless potential of human imagination. For millennia, the moon has been more than just a celestial body. It's been a canvas for human imagination, a muse for artists, and a mirror reflecting our deepest hopes and fears. From the ancient myths of the Greek goddess Selene to the haunting verses of poets like Pablo Neruda, the moon has inspired countless stories, songs, and dreams. It's a symbol of mystery, romance, and the unending quest for knowledge. But as we stand on the brink of mining its resources, we must ask ourselves, how will this new chapter in lunar exploration reshape our cultural connection to the moon? Moon mining represents a profound shift in how we interact with our closest cosmic neighbor. For centuries, the moon has been a distant, untouchable beacon, a place of wonder, not industry. But as robots begin to extract water, metals, and other resources, the moon is being transformed from a symbol of the unknown into a practical destination. This shift could change how we perceive the moon in art, literature, and culture. Will it still inspire awe and creativity, or will it become just another frontier for economic gain? At the same time, this new era offers an opportunity to reimagine the moon's cultural significance. Imagine a future where lunar mining fuels a renaissance in space-themed art, where poets and painters draw inspiration from the stark beauty of lunar landscapes and the ingenuity of human endeavor. The moon could become a symbol not just of exploration, but of sustainability and innovation, reminding us of our capacity to dream big while respecting the worlds we inhabit. Yet, as we harness the moon's resources, we must also consider how to preserve its cultural legacy. The moon is home to sites of immense historical and symbolic value, from the Apollo landing sites to its untouched craters and valleys. These places are more than just geological features, they're landmarks of human achievement and imagination. Protecting them isn't just about respecting the past, it's about safeguarding the stories and symbols that unite us as a species. This balance between progress and preservation is a delicate one. Moon mining could provide the materials needed to build a sustainable future, but it must be done in a way that honors the moon's role in our collective consciousness. This means establishing guidelines to protect culturally significant sites, ensuring that mining operations don't erase the very history and beauty that make the moon so special. It's a challenge that requires collaboration between scientists, policymakers, and cultural leaders, each bringing their unique perspective to the table. The moon is more than a resource, it's a testament to human creativity and resilience. It's a reminder that even as we reach for the stars, we carry with us the stories and symbols that define who we are. As we embark on this new chapter of lunar exploration, we have the chance to create a future where the moon remains a source of inspiration, not just for us, but for generations to come. This is the cultural significance of the moon, a bridge between our past and our future, a symbol of what we've achieved and what we're capable of. And as we mine its resources, we must remember that the moon's true value lies not just in what we take from it, but in what it gives to us, a sense of wonder, a spark of imagination, and a reminder of the boundless possibilities that await us in the cosmos. As the dream of moon mining takes shape, it's not just private companies driving the charge. It's a collaborative effort led by some of the world's most renowned space agencies. NASA, the European Space Agency, ESA, China's CNSA, and others are at the forefront, pooling their expertise, resources, and vision to turn this ambitious goal into reality. But with so many players involved, how do these agencies work together, and what challenges do they face in turning the moon into a shared resource hub? NASA, for instance, has been a trailblazer in lunar exploration for decades. With its Artemis program, the agency isn't just aiming to return humans to the moon, it's laying the groundwork for sustainable resource extraction. From developing advanced robotics to testing new mining techniques, NASA is pushing the boundaries of what's possible, but it's not working alone. Through initiatives like the Artemis Accords, NASA is fostering international partnerships, inviting other nations to join in the effort and share the rewards. This spirit of collaboration is key to making moon mining a truly global endeavor. Similarly, the European Space Agency has been a vital player in this lunar renaissance. ESA's focus on sustainability and innovation is driving the development of cutting-edge technologies, from autonomous rovers to 3D printing systems that could use lunar materials to build infrastructure. By working closely with NASA and other partners, ESA is helping to create a unified approach to lunar exploration, one that prioritizes cooperation over competition. China's CNSA, meanwhile, has made significant strides with its Chang missions, demonstrating its capability to land on the moon, collect samples, and even explore its far side. The agency's ambitious plans for a lunar research station highlight its commitment to long-term lunar exploration and resource utilization. While CNSA approach is often independent, its contributions are undeniably advancing the global effort, offering new insights and technologies that benefit everyone. But coordinating these efforts isn't without its challenges. Different nations bring different priorities, regulations, and technological capabilities to the table. Aligning these diverse interests requires careful diplomacy and a shared commitment to the greater good. Agencies must navigate complex questions about resource rights, environmental protection, and equitable access, all while ensuring that their collaboration remains transparent and inclusive. One of the most promising aspects of this international effort is its potential to bridge divides. Space exploration has a unique ability to unite people across borders, reminding us of our shared humanity and common goals. By working together, agencies like NASA, ESA, and CNSA are not just mining the moon, they're building a model for how humanity can tackle big challenges collaboratively, whether in space or here on Earth. The moon is more than a destination, it's a test of our ability to cooperate on a global scale. As these agencies continue to pioneer new technologies and policies, they're setting the stage for a future where the moon's resources are shared equitably, and its exploration benefits all of humanity. This isn't just about space, it's about what we can achieve when we work together, reaching beyond our differences to grasp the stars. Through this collective effort, the moon is becoming more than a symbol of exploration, it's a beacon of unity, proving that even the most ambitious dreams are possible when we join forces. And as we take these next steps, we're not just shaping the future of the moon, we're shaping the future of our world. Imagine a future where the moon isn't just a distant glow in the night sky, but a bustling hub of human activity, a place where people live, work, and thrive. This isn't the stuff of science fiction anymore, it's a vision that's becoming increasingly tangible thanks to the potential of moon mining. By extracting and utilizing lunar resources, we're not just unlocking the moon's riches, we're laying the foundation for something even more extraordinary: permanent human settlements on the moon. At the heart of this vision is the idea of sustainability. To build and maintain a lunar colony, we'll need a steady supply of materials, and shipping everything from Earth is simply too costly and impractical. This is where lunar mining comes in. The moon's surface is rich in resources that can be used to construct habitats, produce oxygen, and even generate energy. For instance, regolith, the loose layer of dust and rock covering the moon, can be processed into bricks or 3D printed into structures, creating the building blocks for lunar homes. Meanwhile, water ice hidden in shadowed craters can be converted into breathable air and drinking water, sustaining life in an otherwise inhospitable environment. But building a lunar colony isn't just about materials, it's about creating a self-sustaining ecosystem. This is where AI-powered robots play a crucial role. These machines can handle the heavy lifting, from mining resources to constructing infrastructure, all while operating autonomously in the moon's harsh conditions. Imagine robots building habitats, assembling solar panels, and even maintaining life support systems, ensuring that the colony runs smoothly with minimal human intervention. It's a partnership between humans and machines, where each complements the other's strengths to create a thriving lunar community. Of course, living on the moon comes with its own set of challenges. The lack of a protective atmosphere means colonists will be exposed to harmful radiation and extreme temperature swings. There's also the issue of the moon's low gravity, which can have long-term effects on human health, from muscle atrophy to bone density loss. Overcoming these obstacles will require innovative solutions, from radiation-shielded habitats to exercise regimens designed to counteract the effects of low gravity. AI-powered systems can help monitor and manage these challenges, ensuring the safety and well-being of lunar residents. What's truly exciting is how lunar colonization could transform our understanding of sustainability and resilience. By learning to live and thrive on the moon, we'll develop technologies and practices that could be applied back on Earth, from efficient resource management to advanced life support systems. It's a two-way street, where the lessons we learn on the moon could help us tackle some of our planet's most pressing challenges, from climate change to resource scarcity. The moon isn't just a stepping stone for space exploration, it's a potential home. By harnessing its resources and overcoming its challenges, we're not just building a colony, we're creating a blueprint for humanity's future in space. And as we take these first steps toward lunar living, we're reminded that the moon isn't just a destination, it's a promise of what's possible when we dare to dream big and work together. This is the promise of lunar colonization, a future where the moon is more than a distant world. It's a vibrant, thriving extension of humanity's reach, a testament to our ingenuity and a beacon of hope for generations to come. As we look toward creating a future where humans live and thrive on the moon, one question stands out. How do we build a sustainable, self-sufficient colony in such an unforgiving environment? The answer lies in artificial intelligence and robotics. These technologies aren't just tools, they're the architects of a new lunar civilization, capable of transforming the moon's barren landscape into a vibrant, habitable outpost. From constructing habitats to growing food and managing resources, AI-powered robots are poised to become the backbone of lunar colonization. Take habitat construction, for example. Building structures on the moon isn't as simple as erecting a house on Earth. The materials need to withstand extreme temperatures, radiation, and micrometeoroid impacts, all while being lightweight and efficient to transport. Here's where AI steps in. Robots equipped with advanced algorithms can analyze lunar soil or regolith and process it into building materials like bricks or concrete. These machines can then assemble habitats with precision, using 3D printing technology to create airtight, radiation-shielded structures that provide safe living spaces for astronauts. It's a process that combines innovation with necessity, turning the moon's own resources into the foundation of human life. But a lunar colony isn't just about shelter, it's about survival. Growing food on the moon presents a unique set of challenges, from the lack of soil to the absence of a natural atmosphere. AI-powered agricultural systems are stepping up to the plate, quite literally. Imagine a greenhouse on the moon, where robots monitor and manage every aspect of plant growth. These systems can adjust light, temperature, and nutrient levels in real time, ensuring that crops thrive in a controlled environment. Some designs even incorporate hydroponics or aeroponics, eliminating the need for soil altogether. The result, fresh, nutritious food grown locally, reducing the need for costly and unreliable resupply missions from Earth. Resource management is another critical area where AI shines. On the moon, every drop of water, every ounce of oxygen, and every watt of energy must be used efficiently. AI systems can track and optimize resource usage, ensuring that nothing goes to waste. For instance, water extracted from lunar ice can be split into hydrogen and oxygen for fuel and breathable air, while waste products can be recycled back into the system. These closed-loop systems, guided by AI, create a self-sustaining ecosystem that minimizes reliance on Earth and maximizes the colony's independence. What's truly remarkable is how these technologies work together to create a cohesive, autonomous environment. AI doesn't just manage individual tasks, it orchestrates the entire colony, from construction and agriculture to energy production and waste management. This interconnected network of systems ensures that the colony runs smoothly, even in the face of unexpected challenges. For example, if a solar panel malfunctions, AI can redirect power from other sources or deploy a robot to perform repairs, all without human intervention. It's a level of coordination that's essential for survival in such a remote and hostile environment. The moon isn't just a destination, it's a proving ground for the technologies that will define humanity's future in space. By mastering AI-driven colonization on the moon, we're developing the tools and strategies needed to explore and settle other worlds, from Mars to the asteroids. These advancements aren't just about survival, they're about creating a sustainable, thriving presence beyond Earth, one that reflects our ingenuity and resilience. AI-powered robots are more than just machines, they're the pioneers of a new era, shaping the moon into a place where humanity can flourish. And as we take these first steps toward lunar colonization, we're not just building habitats, we're building a future where the stars are within reach. As humanity edges closer to establishing a permanent presence on the moon, we're not just confronting technical and logistical challenges, we're also facing profound ethical questions. Colonizing the moon isn't just about building habitats and mining resources. It's about deciding how we, as a species, will treat this new frontier. What rights will lunar residents have? How do we balance progress with preservation? And what responsibilities do we owe to both the moon and Earth as we embark on this journey? These aren't abstract debates, they're urgent issues that will shape the future of lunar colonization. One of the most pressing ethical dilemmas revolves around the rights of future lunar residents. Will they be considered citizens of their home countries, or will the moon become a new jurisdiction with its own laws and governance? Establishing a fair and just legal framework is crucial, especially as we consider the potential for private companies to play a leading role in lunar development. Without clear guidelines, there's a risk that lunar residents could find themselves in a legal grey area, with limited protections or representation. This raises important questions about accountability and equity, ensuring that those who live and work on the moon are treated with dignity and respect. Another critical issue is the environmental impact of lunar colonization. While the moon may seem like a barren, lifeless world, it's not without its own delicate balance. Mining, construction, and other activities could alter the lunar surface in ways that are irreversible. For instance, extracting water ice from permanently shadowed craters could disrupt these unique environments, potentially erasing valuable scientific data or even creating long-term geological instability. Balancing the need for resources with the preservation of the moon's natural state is a challenge that requires careful planning and ethical foresight. But the ethical implications of lunar colonization extend beyond the moon itself. How will our activities there affect Earth, For example, launching missions to the moon requires significant energy and resources, contributing to carbon emissions and other environmental impacts. While the long-term benefits of lunar exploration, such as clean energy from helium-3 or advancements in sustainable technology, could outweigh these costs, we must still consider the immediate consequences of our actions. It's a reminder that our choices on the moon are deeply connected to our responsibilities here on Earth. So, how do we ensure that lunar colonization is done responsibly and equitably? One approach is to treat the moon as a global commons, where resources are managed collectively for the benefit of all humanity. This could involve creating international oversight bodies to regulate lunar activities, ensuring that mining and construction are conducted sustainably and transparently. It might also include mechanisms for sharing the profits or technological advancements derived from lunar resources, helping to bridge the gap between developed and developing nations. At its core, the ethical challenge of lunar colonization is about more than just rules and regulations. It's about values. What kind of future do we want to create, both on the moon and on Earth? Will we approach this new frontier with greed and competition, or with cooperation and foresight? The choices we make today will set the tone for how humanity explores and inhabits space, shaping not just the destiny of the moon, but of our species as a whole. The moon is more than a destination, it's a test of our ability to dream big while acting responsibly. As we take these next steps, we're not just building a colony, we're defining the values that will guide us as we reach for the stars. And in that challenge lies an extraordinary opportunity to create a future that's not just prosperous, but just sustainable and truly out of this world. The moon is more than a destination, it's a launchpad for humanity's grandest ambitions. While moon mining and colonization are monumental achievements in their own right, they're just the beginning of a much larger story. These efforts aren't just about unlocking lunar resources, they're about preparing us for the next great leap, exploring deeper into space. From Mars missions to the possibility of interstellar travel, the moon is the first step in a journey that could redefine our place in the universe. Imagine the moon as a cosmic training ground. By mastering the challenges of living and working in such a harsh environment, we're developing the skills and technologies needed to explore even more distant worlds. The lessons we learn from lunar mining, how to extract resources sustainably, how to build habitats in low gravity, how to operate autonomously in remote locations, will be invaluable as we set our sights on Mars. The red planet, with its thin atmosphere and vast, dusty plains, presents its own set of challenges, but the moon is teaching us how to adapt, innovate, and thrive in environments that seem inhospitable at first glance. AI will play a pivotal role in this journey. The same autonomous systems that power lunar mining robots could guide rovers across Mars' rugged terrain, analyze soil samples for signs of life, or even construct habitats for future Martian colonists. These machines aren't just tools, they're extensions of human ingenuity, capable of operating in environments where humans can't yet go. As AI continues to evolve, it will enable us to explore farther and faster than ever before, bridging the gap between our dreams and the reality of space travel. But the moon's significance extends beyond Mars. It's a proving ground for technologies that could one day take us to the stars. For instance, the same fusion technology that might one day harness helium-3 from the moon could also power spacecraft on interstellar missions, offering a clean, nearly limitless energy source for long-distance travel. Similarly, the closed-loop life support systems being developed for lunar colonies could sustain astronauts on journeys lasting years or even decades. These advancements aren't just about reaching new worlds, they're about ensuring we can survive and thrive once we get there. Of course, the path to deeper space exploration won't be easy. It will require unprecedented levels of collaboration, innovation, and determination. But the moon offers a glimpse of what's possible when we combine these elements. It's a reminder that even the most daunting challenges can be overcome with creativity, perseverance, and a shared sense of purpose. By working together across nations, industries, and disciplines, we can turn the dream of interstellar travel into a reality. The moon is more than a stepping stone, it's a symbol of humanity's potential. As we mine its resources and build colonies on its surface, we're not just shaping the future of lunar exploration, we're laying the foundation for a future where the stars are within reach. And in that future, the moon will stand as a testament to what we can achieve when we dare to dream big and work together. This is the promise of the moon, a launchpad to the cosmos, a place where humanity's journey into space begins. And as we take these first steps, we're reminded that the greatest adventure of all is still ahead of us, a journey that will take us beyond the moon, beyond Mars, and into the vast, uncharted expanse of the universe. As we wrap up this exploration of moon mining, it's clear that this endeavor is far more than a technical feat. It's a profound shift in how we view our place in the universe. From the cutting-edge robots that navigate its rugged terrain to the ambitious plans for lunar colonies, the moon is no longer just a distant dream. It's a tangible frontier, brimming with potential to reshape industries, fuel innovation, and inspire generations. But with these opportunities comes a responsibility to tread carefully, balancing progress with preservation and ambition with ethics. What makes moon mining so remarkable isn't just the resources we might extract, it's the lessons we'll learn along the way. Every challenge we face, from navigating the moon's harsh environment to addressing the ethical implications of resource extraction, pushes us to think bigger and act smarter. These lessons aren't confined to space, they ripple back to Earth, offering new ways to tackle global challenges like energy scarcity, environmental sustainability, and resource management. The moon, in a sense, is a mirror reflecting both our potential and our responsibility as a species. The journey ahead is as much about collaboration as it is about innovation. From international space agencies to private companies, the efforts to unlock the moon's secrets are a testament to what humanity can achieve when we work together. But this unity isn't just about pooling resources, it's about sharing a vision where the moon isn't just a source of materials, but a symbol of hope, curiosity, and unity. It's a reminder that even in the vastness of space, our greatest strength lies in our ability to connect, collaborate, and dream collectively. As we look to the future, the moon stands as a beacon of possibility. It's not just a stepping stone to Mars or beyond, it's a destination in its own right, a place where science, technology, and imagination converge. The discoveries we make there will shape not just the future of space exploration, but the future of life on Earth. From clean energy solutions to sustainable living practices, the moon offers a glimpse of what's possible when we dare to think beyond our planet. So, what's next? The answer lies in the choices we make today. Will we approach this new frontier with a sense of responsibility and unity, or will we let competition and self-interest cloud our vision? The moon is more than a resource, it's a test of our values, a challenge to rise above our differences and work toward a shared future. Thank you for joining us on this journey through the mysteries and marvels of moon mining. It's a story that's still being written, and you're part of it. What do you think about humanity's next giant leap? Share your thoughts in the comments below. We'd love to hear your ideas, questions, and dreams. The moon is waiting, and the adventure is just beginning. Together, let's discover what lies beyond the horizon.